Let's talk about blockchain storage.
Our platform is actually designed for very complex use cases which cannot rely on events and calls, which are like the typical source of data for blockchain analytics today. So we provide the multi-chain data, which is natively like multi-chain. So our data sets are from the very beginning like multi-chain. So whenever you are interested in querying data across multiple chains, it's like natively supported in our data sets. And we provide the same data as others, like all the events, calls, transactions, blocks, full history of everything. But we also focus on storage information, storage, which is like the major topic of this talk. I will focus on storage, and we'll try to convince you how you can analyze data using storage in completely different way. We provide also some other types of data that can be used for various edge case analytics, like, for example, full history of reverts, not only reverted transactions, but also reverted events, reverted changes in storage, because many things can happen in blockchain execution that then got reverted when the whole transaction is reverted. Normally, it's not preserved, it's not stored in the node. You can find it in our data. We even provide the full history of transient storage, the thing that was introduced with the Dencun hard fork. So storage that is temporal, something that's stored only during the transaction execution, and it's not preserved after the transaction ends. Still, if you want to have like full insight into the history of execution, you need this information, and you will find this information in our data sets. So as I said, we provide multi-chain data, which has all those things that you are very used to for blockchain analytics, plus the storage information that I would like to focus a little bit more during this, this short talk. So as you know very well, in blockchain, we basically have, everything is about storage. Blockchain is a machine that stores some information in time in a very secure way. And this storage is decentralized, is permissionless, is something that people can use to verify many things, like, for example, balance of your tokens. And you have actions that change this storage. Actions read information from the storage, and they write to storage. So basically, every action in blockchain history is about doing some changes in storage. And every action, or many actions today, they emit events. This is like the standard thing that was introduced at the very beginning of the concept of EVM, creation of concept of EVM, that people will need to analyze data. And because people will need to analyze data, Ethereum creators, they introduced this concept of events, which are kind of logs that developers can implement in their contracts, and they emit some information that then can be easily queried and used for analytics. And it is like the basic, very popular approach to analyzing everything in blockchain history. We look at events which are actually results of some actions, because when you execute transaction, you actually execute some contracts, and in this contract code, you have actions that emit some events. So if I transfer token, I emit event, transfer event that is stored and easily accessible. I can then get history of all events. This is like very standard way of analyzing history, something that we are very, very used to. But there are many problems with events. They are becoming more and more hard to use. First, because events are costly. Like emitting events, it costs you money. So more and more contracts, they try to like minimize the gas spent for the contract execution, and they try not to emit event. Some contracts today, some protocols, they completely like stop emitting any events. Like, because it's not obligatory. Like some standards, like for example, ERC20, they require you to emit event. But other than that, it's like up to you. If you don't want to emit events, you don't have to. So more and more contracts protocols today try to minimize the cost of gas by minimizing the number and scope of events that they generate. Another thing is you always have to remember that events show what developer wanted to show you. It's implemented in the contract code, and it's emitted only when developer wanted to emit this event, and it contains only information that they want to be included in this event. So basically, events, they show you what developer wanted to show you. It's not necessarily a bad will that somebody is trying to hide something, but somebody may like forget about something. Or people may find something new, interesting, that was not implemented in the original contract. And in such case, it's very hard to do anything about it, because if the event is not implemented in the contract code, this event is simply not available. You cannot like add it retroactively. And of course, events, they have very limited number of parameters. If they are very, very complex, they cost you more. So people tend to emit simple events with very limited number of information. So again, for simple things, they are good enough. For more complex things, sooner or later, you will realize that events are not enough. And I would say that events are completely redundant and completely unnecessary. You can do whatever you want. You can analyze exactly the same things without events. You don't need events to analyze everything that you today analyze using events. Why? Because actually everything is in the storage. Storage is the ultimate source of everything. The fact that you own a token is not because somebody like aggregated historical events, transfer events, and realized that you should have some tokens. You have tokens because it's written in the storage. So the storage is always the ultimate source of truth. And actually, this is the only thing that is important. So if you have access to storage, to every single change in storage, you can get absolutely the same information that you get from events, because you don't need transfer event. If you see changes in the storage, if you see that in one address it was decreased, in another address it was increased in the same operation, you can easily get the fact that the tokens were transferred. So you don't need events if you have full access to the storage. But it's not that easy. Working with storage is extremely hard. When, again, when EVM was designed, nobody was thinking about using storage as a source of analytics. This is why developers, they created events as something that's usable and easy to use. Because storage, it's big, it's hard to access, actually, and it's very hard to make any sense out of it. First of all, as some of you know, it's not easy to get the storage information from the node, because most of the storage information is in a hashed form. If you have hash map, like balance of, very popular thing, this uses some storage locations, and those storage locations that are calculated as a hashes of owner address and the memory slot. So actually, if you see hash, you cannot reverse this hash, and you cannot just by looking at the node see who is the owner of the token, the owner for this balance that's written in this specific memory address. This is why everybody knows you cannot reverse, or you cannot iterate over hash maps, right? You cannot just easily look at the node storage and get list of owners of tokens, right? You cannot get list of owners of tokens just by looking at the balance of hash map in the node storage. Because these are hashes, they cannot be reversed. This is how it's designed. This is one thing that makes working with storage very, very hard. It's a very easy thing. If you, for example, work with iterscan, iterscan shows you the storage changes for every transaction. You can go there and you will see like huge hashes mostly that cannot be used for anything. Another thing, another problem with storage is this ambiguity, which means that the same location in storage can have different meanings. Because, for example, you may have a diamond pattern contract. You know, diamond pattern contract is a contract that has one proxy and multiple implementations at the same time. And two different implementations may use the same storage slot and may have like completely different usage for this and different meaning for the same storage location. This is not like very, very often. It's not happening quite often, but it's possible. Another thing is it's huge. Like this blockchain storage is really huge, very big source of information. And to analyze anything using storage, it requires lots of analytical skills. It's very technical, low-level stuff. So this is the reason why people mostly don't use storage for analytics. This is why everybody goes to places where you find events and try to build analytics using events, because working with storage is very, very hard. And what we do, we actually try to solve the problem. First thing is to make the storage information accessible. To do it, as I said, we cannot just query the node. Because if we ask the node for history of transactions, like using RPC standard way of getting history of transactions, we will not get this data because it's hashed. And some information is like forever lost. For example, imagine that you have one transaction that changes some storage 3 times, node doesn't store it. Node has only a value before transaction and after transaction. So node does not store, does not provide you the information of anything that happens inside transaction. I think it's even worse because it's at the beginning of the block and at the end of the block. So actually, if you have multiple transactions changing the same storage slot, if you ask the node, you will never get this information. This is how node is designed. So we created our custom tracer, which is extending the functionality of standard EVM nodes. And with this custom tracer, we actually replay every transaction and we get all those storage changes, every single storage change, including the transient storage, and we get it in pre-hashed form. So we don't see that hash was changed, but we see that balance of myself was changed. So we see the keys that were used in hash maps and many other things. So first thing is to get this information in pre-hashed form. And second thing is get every changes. So basically every operation that changes the storage in smart contract storage. Another thing is to make it more useful for people. So we also decode this information, because what we get is we get information that it's slot number 2 for key 0x something something. It was changed from A to B. But what is slot 2? If you have contract code, you can quite easily get the variable that is actually represented in slot number 2. So you can quite easily translate slot number 2 to balance off or to reserve 0 or anything like this. So you give the meaningful names to every variable that is used in the storage if you have contract code. For this, we created our custom parser for contracts. Today, Solidity compiler, it gives you actually the storage layout, but because we need a slightly different and deeper information, we actually parse ourselves every contract that's available. So for any contract that we can get source code for, we are decoding, so like giving the meaningful names and proper types. Also, if we know what is the variable, we can not only give it a name, but we also can represent the content of this memory location in a proper type. Then we put everything in a multi-chain database where we integrate this with blocks, transaction, events, calls. So basically, you can use all of this because every storage change, it happens in the context of specific call, of specific transaction, a specific block. So this context information might be very, very interesting. And then on top of this, we provide some analytical fronts. But we realized pretty quickly that it solves only one problem. It solves problems of availability. So you can have access to those storage diff in pre-hashed form, decoded, but still people cannot use it. Still, it's very complex. Still, it requires lots of analytical experience. And compared to events, which are very good for analytics, because every event is actually, you may call it also observation, because it happens at a specific moment in time and has some measures, some dimensions potentially. So it's very easy to aggregate them. It's very easy to build queries using events. With storage, it's not the case because changes in storage have completely different nature. And we realize that even if we provide every single change in storage, and we provide this meaning, like names and types, it's still very hard for people to analyze it. And we started thinking about how to solve these problems of complexity. And what we are working on right now is what we call ecos. Ecos are similar artifacts, like events. So they are emitted in a specific moment. So you can emit echo when something happens, which means that you can emit echo when block starts, when transaction starts, when specific function is called, when specific slot in storage is changed. So you define the moment in time in execution of transaction when echo is emitted, and you define the parameters, like for events, which are calculated using the whole blockchain storage at this specific point in time. So echo, so when you define this trigger point, for example, emit this whenever new owner is added to the multisig, which means when the list of owners is changed. So whenever list of owners is changed, by any way, I don't care how it was changed. I'm just looking at storage, and whenever the list of owners was changed, emit this echo, which has every information that uses any piece of storage at this specific point in time. So at the end of the day, you get something that looks like events because they are like hooked in specific moments in execution of transactions and provide you with the list of parameters that you define. But how it differs from events? First of all, they avoid traditional limitations because they are not on-chain. This is something that you calculate off-chain using the data that you get from the node. So if you have like database with full history of every single storage change, you can calculate whatever you want off-chain, like using this data, building some queries, some calculations, some formulas that use storage. So basically, it does not cost you nothing in terms of gas. Of course, it costs you some computing power and computing this off-chain, of course, is also connected with some costs, but it's like completely different thing. They provide you complete transparency because you get what you want. It's not that somebody emitted event at one point in time. It's you wanted to see what happens in this specific moment. Because you have access to the whole blockchain state, you can like include information from other contracts that were not involved in this execution. You think about, for example, you see the transfer, and you to the typical transfer event, you can add the prices, for example. You get the state of some pools, Uniswap pools, you calculate price at this exact moment, and you create something that's like transfer plus prices. Or you generate something that's exactly like transfer, but also includes the balance of the receiver after the transfer. So you see that I transferred to Krzysiek 10 euros, then it, and the balance of Krzysiek wallet after the transfer is 1,000 ETH. Right? Something that people need, but it's very hard to get from traditional events. So you can include basically anything. And if you have multi-chain database, you actually can, in theory, include also information from other blockchains. Because in the moment when this transfer was executed, you can connect using time what was the price on other chain, right? You are not limited to the scope of the storage of this specific chain because you can join information from multiple chains using time. It's not perfect, of course. That's the only way to like integrate information from multiple chains, but you can do it. So that's what you get. And some examples. So maybe before. So they are generated like directly from the blockchain state. If you have access to full state, you can transform this state because eco is nothing else like transformation of the state, transformation of storage. It's a formula that makes it more useful for people. We don't generate any new data. We just transform existing data. You can easily calculate it retroactively for the whole history. Some of you probably are familiar with the concept of shadow events, something that's also a very interesting concept. And it's also like in the same, struggles to solve similar problems, problems that some events are not available or you want to have different events. With shadow events approach, you actually modify contract code, you add some events that you want to be included, and you replay the contract. Like you re-execute the whole history using EVM, but with modified contract, which is very costly because, you know, it requires like execution of the whole history. And it's not perfect because if you change the contract code, because basically shadow events changes the contract code, it may interfere with the execution. So just by adding new event, new shadow event, you may change how the contract is executed. Because things change, like it's another different action, real action in the contract execution. So we avoid all those limitations because you do it like completely retroactively just by querying and building some formulas on existing data. So you define when and what. And that's the definition of events. At the end of the day, you get just the data set that you can analyze in exactly the same way as you analyze events today. So very simple examples. This change of signers. You have safe wallet, like probably everybody uses some multi-sigs here. Normally, how you see who is the signer of the wallet? You look at the UI, right? You go to the safe web page and you look at UI and you see list of signers. If you want to be like do it yourself, you don't trust this UI, you look for new signer events. Okay, there's something like new signer event. So you look for new signer events and or change signer or remove signer, and you iterate over this history of events and you see that what's the list of events today. It doesn't work. If you know or you don't know, you can add signer to multi-sig, save multi-sig, in completely quiet way, in a way that it's not shown in the UI. You don't see it in the UI. You see no event, nothing, but there is new signer added. If you are interested, look for a tweet from Bartek Kiepuszewski from L2Bit. He described this once in very details using our data, by the way. And you can actually add this shadow owner to multisig. If you use events, you will never see it until the signer signs something. Example of echo is look at the list of signers, which is just portion of storage. And whenever it's changed, emit new signer echo. So I don't trust developers. I don't trust they have not made any mistakes. I don't trust any, like, potentially, I don't care about any backdoors, anything like this. I just look at the list of signers. List of signers is a portion of storage of this multisig. So whenever it's changed, I'm emitting echo. I don't care how it happened. It happened. So it cannot be hidden from me. Whatever you do, if you change list of signers, I will emit echo. Another simple thing is like extending the transfer. Like probably the most used event is transfer event. But normal transfer events, they lack many interesting informations. And for example, I'm building something and I only want to get the information when there was some change of balance for holders of a token and only big holders of the token. So whenever there is a change in balance of holder of this token, regardless how it happened, I don't care if it was mint, burn, transfer, rebasing, whatever. I don't care. I just look at the balance of. Whenever it's changed, I generate something that has time, what function was used, who was sender, who was recipient, what was amount, what was the sender transfer post amount, what was recipient's balance post transfer, what was the price of this token in Uniswap at the moment of transfer, who was the sender of transaction, how much gas was used. There are many things that I can put together and create this analytical artifact. Then I can analyze it like traditionally, as with any other tools. That's what we are working on now, to make it available and easy to use. We have already all the storage information and whole tooling to provide the storage information. It's just a way to make the storage information more useful and easier to use for people that are used to traditional events. So, as I said, this provides this transparent completeness and basically gives you ability to analyze what you want to analyze, not what somebody else wanted to show you. And that's it. And if you have any questions, I'm almost on time.
How much additional storage is needed to operate and to be able to use echoes in comparison to like EVM machine without those features?
It doesn't impact the EVM machine because, you know, EVM machine is the same. Like EVM machine is the same. The only thing that we change, we add this tracer, which means that if you call the debug trace function using RPC, it doesn't give you just the list of calls or traces, but it also includes all the changes that happen. But then you need to store it somewhere. So it's not impacting like the EVM and node, it's impacting your storage because you need to create like your warehouse, your database where you keep it, or we keep it, right? And provide it to you. So compared to traditional, I think it's like more than twice, storage itself is more than twice all other information that is like transactions, blocks, traces, events, like sum together. Actual number of I don't have time, but if you're interested, we can like look into the data and I can like give you exact numbers. it's not insanely big because the data itself is simple. It's like when it happens. So what was the trace that actually made this change? Also, we have like ordering in trace within a trace, so we know like in which order they happened, which is very important. And then you have the memory address and value before and value after, and then decoded information, which means what was the name of variable, what was the key used, all this. So this data is like many rows, but not very wide rows. So at the end of the day, it's for Ethereum, I'm guessing now, but I think about 50 terabytes for just the storage information. So it's a lot, but not insanely big thing. And of course, to query the whole history, you need to have like the proper database engine to be able to do it. We use Snowflake for this. And again, if I have more time, I can show you, but you can query and fill those queries in really reasonable time. It's like up to a few seconds to get information about full history of changes for some contracts. So it's pretty doable.
Thank you so much, Tomek.
Thank you so much.